K, here's my y, here's my x. I'm going to have k is equal to 25 over 15. And if I take a 5 out of each of those, I'm going to get 5/3. So my equation, y is equal to 5/3 x. Thank you. Yep, thank you very much. So now, when the next part of the equation says, when find me x when y is 10, so what I'm going to do is I'm going to go 10 is equal to 5/3 x. Plug it in, I'm trying to find x. There's a couple ways of doing this in 2 steps or doing it in 1 step. Trying to get x by itself, I'm going to multiply this side by 3/5, the reciprocal of that number. And what I do to one side, I have to do to the other. Now, if I'm showing work, I'm going to solve this down and say, okay, 3 goes into here, 5 goes into here, so I'm going to get x is equal to, and 3/5 times 10 over 1. 3 times 10 is 30. 5 times 1 is 5, so x is equal to 6. Solve it down. Not real difficult, but I mean, it's just kind of setting up that direct correlation, the direct variation as we go through here. Watch it now. Now, 48 deals with a slope and a point, and we have 7/2, and I believe it's 6 1/4 and 22 3/4. Yep. And it says, is this a direct variation through this point? It's 6 1/2. Yep, 6 1/2. So 6 1/2. Now, first of all, one of the things you have is they tell us the slope is 7 1/2. Well, slope on a direct variation is the same as your k value. So really, if this is a direct variation, my equation is going to be y is equal to 7/2 x. That's simple as that, going with direct variation. Now, if it's true, what I know on this point is part of my graph, that means if I plug this x in, and I plug this y into my equation, both sides of my equation should be equal, if it's on that equation, right? So I'm going to plug in 22 3/4 for y.
Could you also do like the y over x equals k?
Could you do y over x to get the same value? That's another way you can do it, yes.
Okay.
You could do it that way too. That's the third way I found out how to do it today. So that's a different way, because I usually just plug in a point, but y over x, and if it simplifies down to the same 7/2, then we direct variation. Now, if the one thing I want to show here is if you're working with fractions, to multiply these two fractions together, I need to change 6 1/2 to an improper fraction, which would be 13 1/2. So you take 2 times 6 is 12 plus 1 is 13 1/2. Multiply those together. Now if I multiply, remember it's multiplying, there's no equal sign, so I'm just multiplying straight across. So I'm going to get 91 over 4. Now if I break that down, I get 22 3/4 equals, and if I divide this out, 4 goes in 90, it looks like 22 3/4. So 22 3/4 equals 22 3/4. Is it a direct variation?
Yes.
Yes. Now that's one way. Now Hannah said, you said, well, y over x is another one, right? I had another person first hour of the day said they used the y minus y1 equals m times x minus x1. Simplified it down and it came up with no y-intercept. Is it a direct variation? If there's no y-intercept, there's a direct variation. That's the third way you can do it. So there's a lot of different ways you can do this. There's no set, say this is the only way you can solve this problem.
Okay, when you do that on the calculator, like the 22.75, if you figure y over x equals k,
Yeah.
you get 3.5, so that does not work.
7 1/2 is the same thing as 3.5.
Okay, yeah.
Okay.
Never mind.
And fraction, and if your calculator is another way you can do that too, that's a good point. Your calculator is 3.5. I don't know if you do an approximation or a control enter, you get a decimal answer, but there is a way to set it up so you get fractions too. So, yeah, it might just work as you go that way too. So, okay, any other questions? Any other ones?
57.
57. If it says y varies directly as x, so I have an equation, y equals kx. Y varies directly as x, right? I don't care what k is a constant of variation. Now 57 says, if I divide my x coordinate by 7, how will that affect my y coordinate?
Well, if you divide it by 700,
Yeah. What do you do to one side?
that's all it was.
Yeah.
Okay.
Yeah, what you do to one side, you have to do to the other, right? If you divide the x by 7, you have to divide the y by 7, and k is just a constant, so let's just multiply together. Now, if it was plus, it would be a little different, but since it's all multiplied together, it's okay.
So like inside y equals x over 7.
Good? So I mean, you would just have to divide by 7 on both sides. And so if x is divided by 7, y is divided by 7.
51.
51. Now 51 is a graphing one. You have, it says here, I believe it says this. It says pick a k value between a -1 and a -0.5. And then graph it out, right? So it's picking a value, just pick a number between here, so set up a direct variation. So I'm just going to say, probably the easiest one is right in the middle here, -3/4 x. K being -3/4. So you're going to set up a -3/4, and then you're going to set up your equation and solve it down. So what I'm going to have here is, okay, one thing about a direct variation is a direct variation always goes through 0, 0. It always starts at 0, 0. So from here, here's my 0, 0. Now my slope for my k value is at -3/4. So that tells me I'm going to go down 3 and over 4. So I'm going to go down 3. 1, 2, 3, and over 4. My first point, go down 3, over 4, and I'm going to keep going. So if I went over 4, this is going to be 4, -3. This is going to be 8 and -6. And I can keep going with points like that. But if I set up my direct variation, that was my equation. I should have 5 points. You should keep going until you 5. You need to go backwards or whatever to get your 5 points. And draw your graph. Now, this one's kind of an open-ended question because it says to pick a value. I can pick a lot of values between a -1 and -1/2. I can say -7/12 or something like that. It doesn't matter. It just depends what you pick. Okay. What else?
We need to do
54. Okay. 54, find the error in the following computation if y varies directly with x squared. Now this one says y varies directly with x squared. So it's a little different, not big. Varies directly with x squared. Now we're just doing the basics. This is a little about as far as we got with the varies. Varies directly with x squared is going to be kx squared. So, I mean, there's a lot of varies directly. I can say y varies directly with the joint of x and y, and inversely with this. We have a lot of ways we can write these equations. We're just doing the basics here, so the kx squared is not too bad. Now this problem says, on here it says, if y is 2 and x is 4, okay? Y is 2 when x is 4. Nothing all drastic, right? Now I can solve for k. Now, when it's x squared, that y equal or k equals y over x doesn't work. Because it's x squared. It's a little different. It would be y equal over x squared. But so I'm just going to solve this down. 4 squared is 16. Now if I divide by 16, I'm going to get, and I'm going to simplify down right away, is 2/16, which is 1/8. So k is equal to 1/8. Okay? I'm going to rewrite my equation. Now, where's my error? I really didn't have an error yet. I'm going to say 1/8 x squared. Now, the second part of this question says y is 3 when x is 9. Okay? So if I say x is 9, I'm going to have y is equal to 1/8 9 squared, correct? 9 squared is 81, so I'm going to have 1/8 of 81, and I'm just going to not really simplify it down, but that's going to be 81/8. Y is 81/8. So is y 3? No. So my error is they computed the wrong number on the second part. And say, when x is 9, y is not 3, y should be 81/8. So there are different ways, again, there's different ways of solving this, it just kind of depends on which way you look at it. So my answer to that one would be, when x is 9, y is 81/8. Questions on that? Anything else? We're coming home with homework here. Nothing, I got one. Let's try this. Oh. There we go. Find me the slope. Find me the slope. Once you find me the slope, find me the equation of the line. So I should do right now. Okay, let's find me the slope. y2 minus y1 over x2 minus x1 is the first one. So when change of y over change of x, I'm just going to make sure everybody's in the slope. My slope would be 5 minus 1 over 3 minus 2, which would be 4 over 2 negatives, make a positive 4/5. Sound good? Slope? Okay, now find me the equation of the line. Put the line in standard form. The line in standard form. Make sure you have your y's with your y's and your x's with your x's. Standard form. Your slope. So if I went into this one, I don't care what point I pick, I'm just gonna go y minus, I'm gonna use the first point here, y minus 5 is equal to m, which is 4/5 x minus 3. Doesn't matter which point I pick. I can pick either point, and it would work, right? Now, if I want to put it in standard form, what would be the first thing I do? Distribute 4/5. So, okay, I'm going to distribute 4/5 through. I've got y minus 5 is equal to 4/5 x minus, now if I take 4/5 times 3, think of 3 over 1, 12 over 5. Was that? Okay, add 5 to both sides. Now there's the thing. A lot of people do that. I mean, when you get in standard form, you want to get x and y on one side, right? Standard form, x and y on one side, numbers on the other. Now, personally, I don't like working with fractions at all. So I could multiply by the common denominator right now to make the problem easier. What would be my common denominator? 5. So I can multiply everything by 5. So I can say, okay, let's multiply everything by 5. And we're going to get 5y minus 25 equals, now 4/5 times 5. 4. 5's cancel off, so you're just going to get 4x minus 12/5 times 5. 12. Now, does that look like a little easier problem to work with? You can do that right away, multiply by the common denominator, and that way you're done with fractions to a point. Now, if I want to get x and y on one side and numbers on the other, what I'm going to do is subtract negative 4x. I'm going to add, if I get my pen to write, maybe not, maybe I won't. There we go. I add 25. So now if I do that, I'm going to get a negative 4x to positive 5y equals, and now this side, that cancels off, I'm going to get 13. Now, I'm in standard form, no fractions. X and y on one side, numbers on the other. And move it down now. Questions on that? I don't know if it's easier to multiply right away. Might be for some. If you only work with fractions, it doesn't matter. Either one works. But sometimes it works going through there. This is standard form again. X and y on one side, numbers on the other. I don't know what the equation stands for. But we're going to work with something today. What we're going to do today, see if I get back to it, is to write equations from word problems. We're going to write equations for word problems. And we're going to start with this one. And this one says, we might have to put a little small print up here. So, and I know it's in the book, but it's talked about here. It says, Jacksonville, Florida has an elevation of 12 feet above sea level. A hot air balloon taking off from Jacksonville rises 50 feet per minute. Write an equation to model the balloon's elevation as a function of time. Okay, so I'm going to let two variables here. I'm just going to start out with this one. I'm going to say h, I'm going to say is my height, and t, for really particular, is time. Okay? So you need to picture what's happening when you write an equation sometimes. Picture what's happening. You get a hot air balloon. That can go on at Jacksonville, Florida. It's going up in the air at 50 feet per minute.
So 50x plus the height of the
Okay. So my height starts off at where? Starts off at 12 feet above sea level. 12 feet above sea level. Right? And then what's happening?
It's rising 50 feet every minute, so 50 feet every hour.
So it'll be 50, and I use t here, but 50 t, and it goes up 50 t. Now, is this and this the same equation?
Yeah.
No, no. Starts at 12 feet above sea level. Starts at 12. Goes up at 50 feet per minute. Now, Some of them don't like using it, and this is the part where we're gonna get different variables. Some of them don't like using h. Some people like to use, okay, this is y, this is x, because that's how you graph it, right? X and y graph. So if you do that, this equation would be y is equal to 50x plus 12. And it doesn't matter if you use y or x, h or t. What does matter, whatever variable you use. Now, if I was using h and t, now I'm going to graph this equation here. I'm going to go on the side here and say, okay, I'm using h and t. T is here, h is here, or something. I had to label my axis, which one goes where. If it's x and y, I really don't know. I don't have to label it because I know x is horizontal, y is vertical. So, but if you're using different letters, you have to label your axis. Now, if I was graphing this equation, where would I start? 12 on the h-axis or y-axis here. Now I'm going to set the scale of 10s here. That should be good. I'm starting right at 12, right there. How about there? What's my slope? 50. 50 over 1. So I can go up 50 over 1. So it's 50 up, feet up every minute over, right? So I'm going to go up 50 because that's my slope. This is kind of in the form of y equals mx plus b. I'm going to have up 50 over 1. Up 50 over 1. Now I'm going to draw my graph. Should be a straight line, a little crooked, but it should be a straight line. What didn't I do? I didn't go to the negatives. Can't go.
They could go below ground. You can't have negative time.
Yeah, you can't go below ground on this one because we're going up in the air, right? You can't go backwards in time. T can't be negative, right? Unless you're time traveling, which I don't think exists yet. But going backwards in time. So there's my point. Now the question up here, and it's hard to read the way it says, interpret the intercept in which the graph intersects the vertical asymptote, or vertical axis. So what does the y-intercept or the h-intercept mean? Interpret. What does that point mean where it crosses there, at that 0, 12? 0, 12, what does it mean? That's where it starts. It started at 12 feet above sea level. So right here, that point right there stands for where it starts. Correct? And then it goes up, right? Now, I was saying this. Now, how about I put this question on the test? Could you come up with a question like that? Not too hard, right? Not too bad. How about I add this question at the end? What's what do you call it? Not logical about this equation? Yeah, it's going to continue. According to this equation, this balloon's going to continue to rise 50 feet per minute forever. It's never going to come back down. Would you want to be in that hot air?
No.
If it's going to keep going up. This equation is kind of illogical because it's going to keep moving up. We're going to have equations. I didn't do the one page. There's equations called piecewise functions. It deals with what happens after so long. And this one doesn't make a lot of sense because it keeps going to the air. Okay? But it kind of gives you the viewpoint after so many minutes. You know, this might be where sometimes we'll define an equation like this and we'll say only from the first 10 minutes or something like that. And then it's after 10 minutes where it's going. It's interesting looking at equations like this. You know, it's amazing sometimes when you think about the math and you think about the calculations of how things work. And we did a problem yesterday that just kind of amazed me a little bit in calculus. I said, think about this. You had a 50-foot light pole, okay? And right next to it, about 30 feet away, you dropped the ball 50 feet high. With that light ball, that ball is putting a shadow on the ground. Imagine that. And we had to calculate how fast that shadow was moving when the ball was dropped into the air. The shallow's moving faster because it's going at a different angle and everything. The shallow's moving at a different speed. The ball is dropping, just dropping, so the ball is moving at a rate of gravity, which is 9.8 feet per second squared, okay? Or meters per second squared, or 16 feet per second squared. You know, and I thought, oh, I kind of thought the same way. It should be close to how fast that ball is dropping. And when we got done with the calculations, the shadow was moving at 1,500 feet per second. You have to think about that. At first I thought, calculations, everything's right, the answer's right. 1,500 feet per second. I never realized the shadow moves that fast. That's a third, almost a third of a mile per second. It's fast.
Probably a little faster than a rifle.
Yeah, so I mean, that shadow's moving huge. I mean, when you think about those calculations, how you calculate, that's just amazing. You know, so.
So if it only started
50 feet. So if at certain times it changes actually. But I mean, right, we were figuring a half a second into its flight. I should say that we were figuring half a second later how fast the shadow moves. Actually, the shadow moves at a different speed every as the ball drops. But we were thinking that at half a second, how fast is the shadow moving? And so it's 1,500 feet per second. I was thinking, that's amazing when you start thinking some of these calculations. That's, like I said, a third of a mile per second. I didn't realize that was happening. And these are the book in the calc book does a good job of making everything applicable. So these are real problems. So I mean, later on it'll go faster, and sometimes it'll slow it down too. But something to think about when you think about these. I never realized the shadow. I need to go look at your shadow when you go outside and see how fast it's moving. When the sun goes down, you drop something. And it should go. Okay. Okay. Look at this question. Let me go for it. I already did that question. Suppose a balloon begins to descend at a rate of 20 feet per second, or per minute, sorry, 20 feet per minute, from an elevation of 1,350 feet, writing an equation to model the balloon's elevation as a function of time. So, this is a little different. Now we're starting at 1,350 feet, and it starts to descend.
Would it be D?
Okay, you're gonna have a negative slope. So really, they use H and T again, so I'm gonna use H and T again. So we're gonna start here. You said a negative slope, so it's going down at 20 feet per second, right? Negative 20 T, and it started at 1,350. Started at 1,350, right? Starts at 1,350 and starts to go down, right? Now I want to think about kind of the same question what we just talked about in the last problem. What would the y-intercept or the h-axis intercept stand for? Okay, how far up? Now this question wasn't on the last question. What would the x-intercept stand for? Not the rate, but it would be the time where it reaches the common ground. This one will have an x-intercept because it's starting up high and going down. Now, if I was graphing this equation on this one, I mean, I'm just going to do a sketch this time. Let's say we start here and it goes down like this, and it goes, if I get my pen to keep following, it goes right here. My graph might be that only bit, right? It's not going to go below the ground. It's not going to go to negative time, correct? So if I was doing a logical graph of this equation, it might be something along this line. Okay? So it's descending as you go. Okay, how about this one? A candle, 6 inches tall after burning 1 hour. After 3 hours, it's 5.5 inches tall. Write a linear equation to model the height, y, of the candle after burning x hours. Write a linear equation. You gonna find it? Now, a lot of people look at this equation and say, I don't know what to do. You know, this is hard to do, and you got a whole bunch of numbers here. What helps is to label your variable. They say height is y, hours is x. Now, if I went up to this equation and rewrote this, it says it's 6 inches tall after burning 1 hour. Okay? X is hours. 1, 6. My next point says after 3 hours, it's 5.5 inches tall. 3, 5.5. What do I have now? I have 2 points. Find me the slope. Find me the slope. Find me the equation. I'll give you a second. Find me slope. Change of y over change of x. Change of y over change of x. Find the slope. Take one, take the other. Yeah, you should know how to do slope. You should know how to do fractions. So you got m is equal to change of y over change of x. Delta y over delta x. So on this equation here, if I took my y's, and I don't care which way, I'm going to start with this point this time. It doesn't matter. I'm going to have 6 minus 5.5 over 1 minus 3. 6 minus 5.5. 1/2. Over -2. Now I can write the -2 as -2 over 1. That doesn't change it. Now what I can do is, if you remember from yesterday, we did fractions. This is the same thing as 1/2 divided by -2 over 1, which when we work with fractions, we multiply -1/2, which makes it a -1/4. Terrible 1/4, but -1/4. Okay? That's my slope, correct? Now if I had to pick, I don't have my points there, if I had to pick one of the 2 points to come up with the equation, which point would I pick? 1 and 6 would make a lot of sense. I probably wouldn't pick the one fraction. Takes a little more work with that. So now if I use 1/6, I'm going to use that point 1/6. Y is equal to, not that y is equal to, start over. Y minus y1 is equal to m times x minus x1. So I have my point here. I got y minus 6, -1/4, x minus 1. Now let's try to get y by itself. Give me a second. It's a lot easier if you try it. Let's try to get y by itself. So I'm going to ask you some questions on this way. So I have to get y by itself. If I was trying to get y by itself, I would have y minus 6 is equal to a -1/4 x plus 1/4. Bringing the -1/4 through. Okay? -1/4 through, -1/4 x plus 1/4. Now what? Try to get y by itself. Add 6. Okay, I'm going to add 6 to both sides. So I have y equals -1/4 x plus 6⁴. Okay, I'm going to ask you some questions on that equation, knowing that what the question read to begin with. My first equation is this. Don't shout out the answer. I want you to just write down what your thoughts are. Here's my equation. What was the original height of the camel? Second question. How many inches per hour does the candle decrease in height? How many inches per hour does the candle decrease in height? And my third and last question on this one is this. How long before the total candle is gone? How long before the total candle is burnt up? A little harder one, but I want you to think about that. You can solve it down and logically thinking a little bit. Yeah, first of all, what was the original height? 6 1/4. Remember that starting point here. This starting point right here tells me my original height. This don't tell me what I started at. So this candle started at 6 1/4 inches tall. I usually get a lot of people when I put this on a test question, a lot of people put down, oh, it said 6 hours, so 6 inches. No, that's after 1 hour. What was it originally? 6 1/4. How many inches per hour does it burn? 1/4. It burns down right here, rate. This is your rate. It burns down 1/4 inch per hour, right? Now my third question, you can do it two ways. First of all, it says, I asked you how long before the candle's height is 0. Well, y stood for the candle's height, correct? I could plug in 0 for this and solve the equation for x, right? Or I could think about it this way. It burns 1/4 inch per hour. How many hours does it take to burn 1 inch? 4 hours, right? How many inches do I have to burn? 6 1/4. Let's do 6 first. So it takes 6 inches would take 24 hours. It takes 4 hours to do 1 inch. 6 inches take 24 hours, right? I still got a 1/4 inch to go. That's another hour, so it'll be 25 hours to burn the candle down. Lots of questions I can ask you on this in different ways. I mean, that one question was, well, I can give you 2 points, a question like we started here, 2 points, and say, find the equation, find the slope, answer these questions. Lots of ways I can put that open. Okay? Questions on that so far? Now, the next thing we're going to talk about in here is scatter plots, and I'm going to do that tomorrow. If you have your calculators, bring them tomorrow because we're going to do some regression and stuff on your calculators. Show you how to set them up, how to do some of that. And I think I have enough over here for the rest. Yeah, I hope I do. We can go from there. So,
I'm not tomorrow, so do I come in like Monday morning?
yeah, that's fine. And also a record or something. I try to write regression because regression is probably one of the things that we use the most. How many do I have? How many calculators? How many people have? I guess some of you do have. How many have a calculator right now? Brand new desk. If you have one, okay. So I need 1, 2, 3, 4, 5, 6, 7, 8. I got 8 people right now. 4, 8, 7. Another card in here. Over there. We will be doing some regression tomorrow, so make sure if you don't get a, we're going to show how to put the equation into the line, best fit, all that kind of stuff. So make sure that. One of the calculators I have, these are the new ones we just ordered too. Just for reference, if you have not hooked your calculator up to the computer, installed the software that came with it. I had one calculator say it was dead. You know, I sent it in a company, and they wrote me back is you have to update the operating system. So even the new ones have to be updated. There must be a new operating system out for the new ones. So if you haven't updated them lately, I'm going to start doing mine probably pretty soon. Updating the calculator. Okay. And if I get my system set up, I can update yours too, just plug it in, going through there, okay? And with this next step, like I said, I'm posting it tomorrow. What I would like you to try to use, and all the iPads will be in here tomorrow, I know all day, but if you're gonna take the test, try to put the picture on Google Docs. Because I'm gonna try to correct it with my notability so I can circle where the problems are. Or circle where the errors are, if there's errors in your problem, show you what you did wrong instead of just saying, fix this. I'm gonna try to do some correcting where I can post it back to Google Docs and you can look at it. So we're gonna try to post it, and if you need help doing that, I can show you a quick way with the iPads tomorrow. Hopefully they're all set up to go. I can show you how to do that real easily. And if you don't have an iPad, Google Docs account, contact me. Because most, actually, I think all my seniors are getting it this week, so I think juniors probably will be soon, so. Maybe I'll have a Google Docs account where you can store information. It's kind of a neat system. So, now your assignment's kind of a weird assignment, so you're going to have to listen closely. This is on page 81. Page 81. Page 81, I want you to do 1 through 7. (15 through 19). 22 through 26.
20 or 22?
22 through 26. For the ones that are going to be gone, if you're in knowledge ball and stuff tomorrow, your assignment's going to be up to 30 the rest. Okay? So, whatever ones I didn't sign through 30, you're getting the rest tomorrow. Okay? So that's kind of what the assignment's going to be. But the ones I skipped for now are dealing with scatter plots. And that's what we're going to deal with tomorrow on the calculator.